Hello everyone, welcome back again. In this video, we're going to make a rotating 3D wireframe cube using only points and lines on a 2D screen with something called 3D perspective projection. So let's get started. Imagine that is our screen, and if you are looking at our screen, it will look something like this from the top view. Let's say we are k distance apart from our screen. The area that is outside of the screen is 3D space, and the center of our screen is 0, 0, 0. Let's say there exists a point in the 3D space that is x, y, z. So if we somehow connect the point to the eye and it intersects with the screen at x0 and y0, and we have to calculate the x0 and y0 with the triangles that are formed here. If you take the triangle and draw it separately, here we can see there are two similar triangles, that is x0 and k as sides of one triangle and x and z plus k as sides of another triangle. We know that the side ratios of two similar triangles are equal. So in this case, x0 by x is equals to k divided by z plus k. With simple algebra, we can bring up these formulas x0 and y0. Remember, the x0 and y0 are the projected points of our 3D point. So let's start implementing these ideas in our code. I'm using JavaScript and HTML5 canvas. It doesn't matter, you can use any other language or any other graphics API that can draw points and lines. Here you can see I have update function and draw functions which run single time per single frame, which updating variables and draw them to the screen. Let's create a class for our point which takes x, y, z in the constructor. This.x equals to x, this.y equals to y, and this.z equals to z. And create project method for this class to project this 3-dimensional point to a 2-dimensional point which is on screen. If you remember from earlier, we need k for projecting the point. K is distance between our face to the screen. So this.x times k divided by this.z plus k. Similarly, let y equals to this.y times k divided by this.z plus k. Right after we project these points, we want to draw them to the screen. So I will create a function called circle which draws the point on a given xy positions with the given radius. So the radius should be based on the distance the point is. For example, if the point is far away from us, it should have small radius. If the point is right in front of our face, right in front of the screen, the radius should be larger. So let's store this ratio in r, and this dot x times r and this dot y times r. The r is also radius for our point. Let's test this out by creating a bunch of points with different locations. Let's create an array for storing our points, and using for loop, let's push 100 points to our points array. Points.push new point. We give different random x position, random y position, and random z position. So let's create a random function which will generate a random number between given range. And I would like to make the center of our screen as origin. So I draw each point by offsetting its x coordinate by half of the width and its y coordinate by half of the height. That's why we have to generate a random number between negative width by 2 and positive width by 2, same for y coordinate. If you look at our points in the console, you can see each one have different x, y, and z coordinates, and we can simply project them to our screen using the project method. I'm using for loop to access each point. We can use for each. I may use that later. So So points of I dot project. Here we have to be careful. I am selecting the k value as 1000. So I generate a random number for z value from 1 to 1000. You have to be careful with it, and we have to offset each point by width by 2 and height by 2. Cool, we got a bunch of points on our screen, and let's try to make the points come towards us. We can do that by decreasing the z value of each point. So points dot for each point. Remember, for each is like for loop, we can access each element of an array. Let's make the radius of the each point a little larger. It's cool, it's looking amazing for me. Let's make the radius even larger, and let's increase the speed. Nice. And we got error that saying that we gave negative radius for it. That means our points gone out of the range in the pixels, and we don't bother them about that now. And we're done with our points, and let's start making our cube. Make a cube class. In the constructor, it will take center and size. Based on the center and size, we can generate 8 vertices of our cube. Let's skip this. I don't want to watch me coding 8 vertices for a long time. Let's make draw method to loop through each vertex to project and draw it. Let's create our draw method, and I will use for each these dot vertices dot for each vertex dot project, and again I will take 1000 as k value. Play around with it, don't break it. By cube equals to new cube, let's put our cube in the center of our screen. So center of our screen is origin, and let's make it 200 by 200 pixels. And let's draw our cube to the screen. As you can see, we got 8 vertices of our cube, but it doesn't look like a cube, but it is. In order to make it look better, we have to draw lines between each vertex, and if you rotate the cube, I'm sure it's damn sure a cube. In order to rotate our points in 3D space, we have to use something called rotation matrix. So we have to rotate our cube at one axis, one at a time. We have to rotate each vertices to make the rotation possible. So these are the vertices dot for each vertex, and I am removing the center position from the vertex because by default, not by default, that's how maths work. So basically it will rotate as making one of its vertices as origin, but in order to make the rotation around itself, we have to subtract the center position and add the center position again after the rotation. So here is the formula for rotating our cube in z-axis. As you can see, vertex dot x is equals to vertex dot x times math dot cosine of angle minus vertex dot y times math dot sine of angle. I will provide these three formulas, the rotation in x and y2 in the description. You can go and check them. So let's try this rotation in update function. As you can see, the cube is rotating in z direction. I am making the dt value not go any higher than 18 in order to prevent some glitches. Similarly, let's make two more methods to rotate our cube in x and y directions. Let's copy this z method and rename it to x. Formula changes a little bit. So after adding those three methods, here is our final cube rotating in three directions. Now what left is connecting those points with lines, which is very easy, very simple. We take three for loops to connect all those points, one for loop for one face, another for loop for another face, and the third for loop to connect two faces. In order to connect those points, we need each point screen xy position, not the world xy position. So I am saying the screen xy position in make by making a properties for the class. And here's the first for loop, which goes from 0 to 4, I mean less than 4, that is 3. So 0 1 2 3, which will connect 4 points. I'm making a function to draw the line which takes 4 parameters, the starting position and the ending position. And if you draw a line between these the vertices of I position to these the vertices of I plus 1 position, when I is less than 3, so it will connect 3 points 0 1 2, and we have to connect the fourth point to the 0th point. Cool, you can see the 3 points are connected. And let's add, if I is greater than 3, we connect the fourth point to the 0 point. Similarly, let's make another for loop to connect the 4 points of the opposite face. So the opposite face will go from 4 to less than 8, and if I is less than 7, we connect the 3 points, and for the last point we connect the 6th point to the, I mean 7th point to the 4th point. And finally the third for loop to connect these two faces, which is I is connected to I plus 4. And here is our beautiful rotating cube. Thank you for watching guys. See you again.